Here's how to draw the velocity versus time graph from a position versus time graph. The key to drawing velocity graphs is to remember that the velocity is equal to the change in position over the change in time, which, if we remember way back from early algebra, is the rise over run, or the slope of a position versus time graph. Now, it may seem like a lot of effort to calculate the slope everywhere on a position graph, but here are some quick tricks that will save you a lot of time. Let's consider our previous problem, where we drew the position graph for a dog on a rocket ship. Here we used critical time points to mark when the dog's movement was changing. Now for a velocity graph, we are going to use these same critical time points, but look at what the slope is at each point. Looking at the first critical time point at t equals 0, we can see that the slope of our position graph is basically a horizontal line, which means the slope is 0. Since the velocity is the slope of position, this means our velocity at t equals 0 is also 0. This makes sense because most rocket ships start at rest. Going to the next critical time point when t equals 4 and the rocket engines have run out of fuel, we notice that the slope is now positive, which we can approximate as a positive 15 meters per second. So on our velocity graph at t equals 4, we're going to put a dot at v equals 15. Now looking at our next critical time point when t equals 6, the dog has reached its maximum height, and the slope of the position graph goes back to a horizontal line. This means that the slope is 0. So at t equals 6 on our velocity graph, we're going to put a dot at v equals 0. If we look just past t equals 6 until our final time point at t equals 11, when the dog reaches the ground, we notice that the slope of our position graph here is negative. And even more so, it's the same slope all the way from t equals 6 to t equals 11. So here the slope is negative 5, and on our velocity graph right past t equals 6, we're going to put a dot at v equals negative 5, and another dot at v equals negative 5 when t equals 11. Now all that's left to do is to connect the critical time points on our velocity graph with straight lines, and you're done. And there you have it. That's how to draw velocity versus time graphs from position versus time graphs.